In this example, once again, we're going to want to be able to describe an image. All right. However, the lens we're doing, so this is an image that's produced from light through a lens. However, here what we've got is we have a negative lens, which means it's going to be a diverging lens. And the object is going to be outside of the focal point. So since we have a negative focal point, that tells us we have a diverging lens. Now, it's going to have a negative 20 centimeters. The object is going to be outside of that range. And so let's determine something about the image. And so we're going to use our favorite equation. 1 upon distance of the image is equal to 1 upon the focal length minus 1 upon the distance of the object. We plug our values into this, and this becomes 1 over a negative 20 centimeters minus 1 over 25 centimeters, because that's what we have. The common denominator of this will be a 100, and so this is going to be equal to a negative 5 over 100 centimeters minus 4 over 100 centimeters, which is equal to a negative 9 upon 100 centimeters. Therefore, the distance of the image is going to be 100 centimeters negative divided by 9. That value is equal to a negative 11.1 centimeter. Now, what this tells us is because that's negative, this is going to be a virtual image. It will not be an image which can be displayed upon a screen or could actually be captured. Now let's look at the magnification of the image, and that's going to be equal to a negative, the distance of the image divided by the distance of the object is equal to a negative 11.1 centimeters divided by the distance of the object, which is 25 centimeters. Now this gives us a, oops, I forgot my negative, it's got to have a negative, 2 negatives. So that's going to give us, this is going to be equal to a positive 0.44 is what the math turns out to be. Now, because this is positive, it's going to be upright, so it will not be inverted. So if the image, or if the object is up, the image will be up as well too. And since this is smaller than 1, that means that the image will be smaller than the object. So what we've learned from this is if we have a diverging lens, hint, hint, all images from diverging lenses are going to be virtual. The object is going to be outside the focal length, so that tells us we're going to have an upright image, which is going to be smaller than the actual object itself. If you have any questions on refraction through thin lenses, please let me know.